Hey guys, this is Estelle Elizabeth Gran. This is Mr. Gran's new baby girl who was born this morning. Now, I'm on about take 6, so if this doesn't work out quite perfectly, at this point, you're going to just kind of get what you get. Now, here is my setup. I am in the bathroom of our hospital room, so bear with me. Hopefully this will be okay. Alright. Here's my little setup. We're going to try to take some notes on here now. This is part 2. Now it's focusing. It didn't last time, which is why I've got some writing on there already. And I've already screwed up enough times that I had to use all my extra copies and tape a little piece of paper over there so I could write on it. Now, what we're doing here is proving that the pairs of triangles are similar. Now this is really similar to when we did congruency. We're going to be looking at the different components that are congruent and why they are, justifying it by a property, and looking at which sides are proportional and justifying that with a little bit of math. So what we've got here is a pair of parallel lines, which means that we have alternate interior angles, and we also have some vertical angles. Now, we could have also chose T and S as alternate interior angles. I just chose these two because I had to pick two of them. So, okay, so we've got that PQT is congruent to RQS because they're vertical angles, the ones in the middle there that I highlighted in red. And then our blue ones, a little shorter to write, hopefully I don't screw it up again. Angle P is congruent to angle R, and that's because they are alternate interior angles. Alternate interior angles. So now that we have that done, the last step will be actually writing the similarity statement. Now, important that we match up the correct angles so everything's in order. So if I start out by saying triangle PQT is similar. Notice I don't have the congruency statement. PQT, P is congruent with R, Q is congruent with Q, and then T is congruent with S. And the justification there is angle-angle similarity. Alright, let's try the next one. See if I can manage not to goof this one up. Alright, a couple of right triangles. One thing I notice right away is that I have 43 here, 47 here. If I subtract 90 and 47 from 180, guess what? I get 43 degrees. So I think I've got enough here to do angle-angle similarity. Now, I already have two 90-degree angles that are given. And so we can say that angle B is congruent with angle E, and the reasoning there is given. They're both 90 degrees. You could also say that they're both 90 degrees. I think I did that in the actual notes, in the note keys. And then our other part, we've got maybe angle F is 47 degrees, and if we do 180 minus 90 minus 43, I think we get that angle C is also 47 degrees. So I could say angle C is congruent with angle F, and the reasoning there is that 180 minus 90 minus 43 is 47, not 44. 47. Now I've got enough to prove by angle-angle similarity, and so triangle ABC is going to be similar. A is 43, that's going to match up with angle D. So triangle D, B is 90, so is E, and then C is 47, excuse me, and so is F. So DF, and that is because of angle-angle similarity. Now we get to the interesting ones. We have to start doing a little bit of math with these. Now, first thing I'm going to do with this is look at triangles like this. I have no information about the angles. I can't make any inferences because there's no there's no vertical angles, there's no alternate interior angles, anything like that. This is going to be straight side length, so this is going to be side, side, side. Here's what I'm going to do. I know I've got two triangles here, right? So I'm going to make this one blue, and I've got sides of 4, 4, and 6. So I have two short sides, and I've got one long side. An isosceles triangle. Pretend that is a nice LG. Then I've got a red triangle, the other part of this. And again, I've got two short sides that are both 6, and I've got a long side that is 9. Now notice that they share a side, right? That one is the long side on the smaller triangle, and then on the larger triangle it's the short side. Now when I set up my ratios to prove that all three sides are similar, here's how this is going to look. I'm going to move this just a hair. I've got two short sides and one long side, and I'm going to show that the ratios of short to short, short to short, long to long are all the same, and one of the shorts and one of the longs are going to be the same side. So first short side I'm going to use 4 and 6, so 4 over 6, and that reduces to 2/3. Other short sides 4 and 6, so 4 over 6, and that also reduces to 2/3. And then our long sides, 6 for the blue one and 9 for the large ones. 6 over 9, and guess what? That also reduces to 2/3. Now, important thing to note here, I did 4 over 6, the blue to the red, 4 over 6, blue to red, and then 6 over 9, blue, the long side of the blue to the long side of the red. You have to keep the order correct here. So if I use the smaller one on top, I have to use the measurements from the smaller triangle on the top for all three of them, or it's not going to work. I'm going to end up with couple of them being 2/3 and one of them being 3/2, and maybe I don't know that I made a mistake there. Maybe I just assumed they're not similar when indeed they are. So then our similarity statement, a little bit of freedom here. If we say PQR, make sure that's on camera, that would be similar to P could go with P, S could go with R, and then R could go with Q. So notice that I'm going PQR, I'm going like to the larger angle here that's opposite the largest side, so I have to go from P to R to S on the red one for this to work out. PRS, Paul Reed Smith guitars. And the justification there is side, side, side. Alright, now a fun one. This is a fun little puzzle type one. You see these a lot in your MCA and ACT stuff. Alright, now here I've got two triangles. One of them is this top portion of the big triangle, and there I've got two side lengths given. One of them is the short side and one of them is the longer side. Then I also have the big overall triangle, and something students often get confused with here is they think that the side lengths are 4 and 6, but actually 2 and 4 makes 6 for the short side of the big triangle, and 3 and 6 makes 9 for the long side of the big triangle. And then one other thing I noticed, a little throwback, both of these triangles use angle J, and there is a special term we had when that happened. So let's take a look here. Now, I need to show, I'm thinking that this is side angle side, so I need to show that two sets of sides are proportional, and then this included side, or angle that's between the two sets of sides is congruent. So, I've got a small side, a short side, excuse me, and a long side. Now for the short sides, 2 for the little triangle, and then 6 for the big triangle. So 2 over 6, that reduces to 1/3. Long would be 3 to 9. That's also 1/3. So we know that the proportions are good, that they're both proportional. Then, for our green angle, we'll use a green pen just to make it colorful. I can say that angle J is congruent to angle J because of the reflexive property. Our old friend, the reflexive property. Now, let's say for our congruency statement, we start out with JKL. That would be similar to JMN, just kind of go in the same direction around the triangle. And that is by side angle side. Like that. Okay. Last one. Hey, I made it through this with relatively few mess-ups. I think we're going to be okay. Here's another pretty common one where you've got kind of this bow tie looking thing. And of my two triangles, I've got on this side, and I've got a short side and a long side. And then, whoa, come on, Mr. Gran, get it together. This is almost done. Then on this side, again, I've got a short side and a long side. Then in the middle there, looks like I've got some vertical angles. Right here and right here. So let's see if this is going to work. Let's see if we can prove that these two triangles are similar. For our short side and our long side, our short sides, if I go blue to red, is going to be 12/16. Now, common mistake people make is they'll try to go 12/20, 15/16, or they go 12/15, 20/16. There are a couple different ways you can do it. Those are examples of ways that don't work, but if we always go the short side of one, like the left side versus the right side, and then the long side left to right, it should work out. Alright, so 12/16, that reduces to 3/4. Then the long sides, 15/20, that also reduces to 3/4. Then our angles, we've got angle TUX is congruent to angle VXW. That should be TXU. Whoops. I should probably write it on the paper. So let's try that again. I'm going to put it down over here. I almost made it through without a major screw up, but I just didn't quite do it. Angle TXU is congruent to angle VX